All right, guys, this is gonna be the last video for this chapter. Pretty sure only two videos this time. Again, we're looking at the same stuff over and over again. So now we're gonna get into confidence intervals for two means, and then significance for two means, and how I could conduct all those. So again, let's start with the conditions. What do we need to be checking before we start these problems? So one, again, you're gonna see a lot of similarities between what we did before in chapter 9 and this. So one, random. Two, M1 needs to be less than or equal to 1/10. Big M1 N2 needs to be less than or equal to 1/10. Big N2. Okay. And then we have to check normality. So a couple ways we do that. A, stated slash population is normal. Okay. B, we have to check CLT. So that means we got to check M1 greater than 30. 2 is greater than 30. Okay. And in the rare scenario, we may have to graph some data, but we'll see about that. So now what is the standard error? So SE, again, remember we're combining things, going back to like chapter 3, right? Remember we don't subtract standard deviations, we only add the variances. So that's what we're gonna do. We're gonna do S1 squared over M1 plus S2 squared over N2. And again, right, this is just another transformation if you think about this, right? We're looking at the difference between two different things, two different random variables, which is another random variable. And so we just have to add their variances together. And so that's what we did. Okay. And so now, again, what does SE tell us? SE says how far x bar 1 minus x bar 2 is from mu1 minus mu2 in standard deviation units. Okay. So now, how do you calculate the t critical value? Well, one before that, sorry. What is the formula for the confidence interval for mu1 minus mu2? Write this out. So here we're going to have, again, remember statistics plus or minus critical value times standard deviation. So what we're going to have is x bar 1 minus x bar 2 plus or minus t critical times the square root of S1 squared, which we just talked about, over M1 plus S2 squared over N2. And remember, this is for confidence intervals. Oh, I put this in the wrong spot. This goes down here. Okay. And so how do you calculate the value of t critical? Use a t-table. We have talked about this before. And then again, remember we mentioned we use the smaller of the degrees of freedom. So whichever is smaller, we're going to use that as our t critical value. Okay. And then on the calculator, what do we use? It's called two sample. It's in the same location, two sample t interval. So try this out. You have a full state plan to conclude here. So try this out. We have some data. You're going to have to put this into some lists, calculate some means. It's really good practice problem. Just try this out. We'll go over this in class. I'll take a look at that. Moving on to the next page. So if we want to do a significance test, we got to define some hypotheses. So remember, confidence intervals, we're just looking for a range of values. Significance test, we're looking for just a null and alternate hypothesis, and we're testing something specific. And so remember, your null is always going to be your baseline. in terms of your population parameters, or if we're looking at means, so again, we're looking at mu's. So we have mu1 minus mu2 is equal to 0. Another way to write that is, or mu1 equals mu2. Right, just add mu2 on both sides. You get that. HA mu1 does not equal mu2. Right, again, look at the problem. It could be less than, it could be greater than, depending on what your problem is. Okay. So what is the evidence for HA? Give two explanations, or what are the two explanations? So here, what we can say is that the evidence for HA will happen by chance alone. Meaning that the difference, and then in the problem above, we're looking at metal music versus classical music. So the difference between metal and classical can happen by chance. Or you can look at the flip side, which is the difference between metal and classic is so large that we would not expect it to happen by chance. We would not expect the differences observed to happen by chance. And then we're not worried about the simulation. Yeah, we're not going to worry about that, so don't worry about part C. But now, the actual test, this part is really important. So now how do we actually do this? So again, we want to use the t distribution is equal to x bar 1 minus x bar 2 minus, so again, statistic, which is x bar 1 minus x bar 2. That's what we're looking for. Minus the parameter, so mu1 minus mu2. Divided by your standard deviation. So we have S1 squared over N1 plus S2 squared over N2. And again, can you use the calculator? Yes. Just be careful, make sure you're setting everything up. So again, it's on the Inspire. It's going to be menu, statistics, stat test, two sample t-test. On the 8384, you're going to go stats, test, and then two sample t-test from there. And again, I'll show you the calculator in class. Okay, so again, the start of the next page is another really good example that we'll look at in class. See if you can do the statement do conclude. And again, we'll look at that together, and we'll go over the answer for sure. Okay, so now the question is, when we looked at proportions, we were able to do this pooling, we were able to combine things. But why can we not combine things? Why did we say no to pooling in this case? So here, I'm going to write that pooling is to estimate a common standard deviation. The benefit is that there is slightly more power due to larger degrees of freedom. Right, when you combine it, you have a larger n size, a larger n. However, if equal variance is not met, then the p-value can be off, and that's why we typically say no, because typically you're not going to have equal variances. So that's kind of where that. So that's kind of why we don't pool for this scenario. Okay, moving on to the last little bit here. So we have a little table. So how do we know whether to use true sample or a pair t-test? So I'm going to just kind of fill this in. So for paired and unpaired. So for paired, we want to label rows and columns. You can't scramble the list, right? Because each, when it's paired, the corresponding values are linked to each other, right? So you can't, for example, like a pretest and a post test, I can't just mix things around because it doesn't make sense at that point. So you can't scramble the tests or the list, sorry. You have the same number of values. In each column or in each row. Here we're looking at the mean difference. Okay, and then if you want an example, look at page 587 in your textbook. For unpaired, we don't care about labels, so no label for row and column. We can scramble this because nothing is really, nothing's matched together. So if you can scramble, it doesn't really make a difference. You can have different number of values. So you can have one column or one column that has slightly more than the other. Here we're looking at the difference of means. Okay, so in the first one, when you're doing paired, you're looking at the average difference between the two things, right? When you're doing unpaired, you're looking at two separate means and you're going to compare the two together, okay? And again, a great example is going to be on page 645 of your textbook. So hopefully that makes sense. Again, if you have questions on that, please let me know because we can definitely look at a lot of that stuff together. And next page is going to be a lot of simulation stuff. So we're going to look at that together in class. We'll kind of go through some of this. Pretty interesting stuff. But yeah, so you can read this problem, see if you can design this experiment, and we'll look at it together and talk about it. It's pretty interesting, and which experimental design is preferred and why it is. But we'll do that in class. So as always, if you guys have questions, please let me know. This is the end of the chapter 10 video notes. And as always, we'll go through the examples together in class. And if you have questions, let me know. Have a great rest of your day.